All right, the last part of section 7.3 is learning how to graph log functions. Well, here's one problem. So if you want to pause the video and copy some stuff down, that's great. I want you to break it into two parts because we're going to graph the exponential function right here, which is y equals 3 to the x, and then we're going to graph its inverse. Now, I've tried to get across to you guys all year long. If you take a college entrance exam and you get a graphing problem, you go, oh goodness, I can't remember what to do. First thing is to make a t-table if you don't know what to do. And then I would always encourage you to pick numbers for x, some that are negative, some that are positive, so you see what's happening on both sides of the y-axis. So I picked -2, -1, 0, 1, and 2. All right, so let's evaluate. Let's say I took -2 and put it in there for x. I would have 3 to the -2 power. Now I'm going to review. Hopefully you remember how to handle negative exponents, but basically what you do is make it a fraction, and then you flip it upside down, or you move the negative exponent to the bottom, and it becomes positive. So 3 to the -2 power is the same as 1 over 3 squared, which is equal to 1/9. So if I put in -2, my y value would be 1/9. Same thing if I put in -1. 3 to the -1 power, you make it a fraction, and you move it to the bottom and make the power positive, which becomes 1/3. That's how you handle negative exponents. All right, and then if I put in 0 for x, 3 to the 0 would be 1. If I put 1 in for x, you'd get 3. If I put 2 in for x, 3 squared is 9, and after that, I'm off my chart. So, let's graph that. -2, 1/9. Now, I'm going to do the best I can again on this graph. It's going to be, actually, I'm going to do it in color. So, I'm going to graph this one in blue. 1/9 is like right next to the x-axis. And then the next point is -1, 1/3, which is probably about right there. And then 0, 1, which is right there. And then 1, 3, which is right there. And 2, 9, which is way up here. And as you can see, my graph is going to look something like this. And we've already talked about graphing exponential functions because you know we've already talked about this line right here, this green line, is the asymptote. The graph doesn't cross that line. All right, well, for my blue line, let's talk domain and range. Domain is all the x values, how far in this direction we go. Well, the graph goes all the way to the left, and this arrow here means the graph will go all the way to the right. So the domain for this exponential function is all real numbers. The range is the y values. That's how far up and down the graph goes. Well, the graph can't get any lower than that asymptote. And it doesn't touch that asymptote, so that means all my y values have to be bigger than 0, because it can't be 0, and then it goes up forever. So you could write it one of two ways. Either infinity, 0. 0 is less than y, which is less than infinity, or the easier way would just be to write it y is greater than 0. And there is your graph of your exponential function. All right, now let's graph its inverse. Well, the first thing we got to do is find the inverse. Now, I'm going to erase this in just a little bit so I have some room here. But in order to find its inverse, remember you take the function and you flip x and y around. And then you solve for y, which in this case is to write it as a log function. So log, and there's the base 3 of x, and the power becomes the answer. If you need to pause the video, please do, because I'm going to erase this, and there is its log function. All right, so y equals log base 3 of x. That's the inverse that we're going to graph, which I'm going to do in red on the same graph. Well, again, we need to make a t-table. And what do? Well, we just said on the last video and in this video, to find its inverse, you switch x and y. Well, all we need to do then is take our table values and switch them around. Because that's its inverse. You switch the x and the y. So now my x's become 1/9, 1/3, 1, 3, and 9. And my y values are -2, -1, 0, 1, and 2. Switch them. Now graph it. 1/9, -2 would be, something like there. 1/3, -1 is going to be there. 1, 0 is right there. 3, 1 is right there. And 9, 2 is right there. Now, log functions have the y-axis as an asymptote. So therefore, my red graph will not cross this green line that I'm drawing right there. As you can see, as best I can, as I can draw it on this smart board, the log function's graph looks like that. Now, if you recall from the video in section 7.2, when we graphed, inverses are always mirror reflections across the line. And again, I'm going to draw this nicely on this whiteboard. It's kind of difficult, but that line right there, is the line y equals x. All inverses are reflections across that line. And if you notice, my blue graph reflects to the red graph across that line. So the blue is the exponential graph. The red is the log graph. And that's what a log function looks like. Now, what's its domain? Well, as I just said, you switch x and y around. So therefore, my domain is really my range. However, you always use x. If you notice, x is greater than 0. All my x values are on that side of the y-axis. So my x numbers are all bigger than 0. And my range will now be the old domain. My range is now all real numbers. You switch these around as well. And that's how you graph a log function. If you have any questions, make sure you ask me in class, but that's the procedure that I want you to follow to do your graphing.